Hello guys, let's see the pulse Doppler radar in this video. Basically, I have started in the last video, but I'll just explain you in brief. So, pulse Doppler radar. So, what happens? Basically, we know that is a starting. Previously, we have used an equation for the blind speed, that is Vn is equal n lambda by 2 Tp, where we can see what basically what's the we can have some problems, right? In the radar, in the airborne radars, what are the problems you have seen? One is like blind speed. It will be there in normal also. This will occurs in this also actually. So but especially blind speeds can is especially difficult in broad to rectify this. Blind speeds in an airborne radar will be very much difficult. Okay. And which operates with a higher frequency. Okay, next. uh, and in addition to airborne, this also suffers the widening of cluster spectrum. That is already we have seen this cluster spectrum. So one of this is this, according to the equation 1, increase in PRF increases the, so when you increase this frequency PRF, that increases the blind speed, right, velocity. So that reduces the number of nulls found within the Doppler space. So let us take, this is the Doppler space. If we increase the PRF, what happens, the number of nulls occurred will be reduced. Okay. And which will but what happens if you increase the frequency? We are actually avoiding the problem of blind speeds, but there will be another new problem will arise, that is called range and ambiguous. Range ambiguity is like when actually if that original target is at 10 kilometers, if you see a target in the radar through the radar system, or if you found the target distance using the radar system, it might show you 5 kilometers. That is the range ambiguity. So that is caused due to high PRF. Okay. So therefore the therefore the trading of Doppler ambiguities for range ambiguities is something that has to be rated in order to obtain the good detection and moving targets at high operating frequencies. So basically what happens, we basically those, if you have, if you want to eliminate Doppler ambiguity, there will be high range ambiguity. If you want to eliminate range ambiguity, there will be high Doppler ambiguity. So there should be a trade-off between them. So basically when you use high frequency, if you use a PRF which is high enough, uh, sorry, we increase the PRF is high enough to avoid problems of blind speed. Blind speed is called pulse Doppler radar. So basically what is this pulse Doppler radar is, when you uses a PRF which is high enough to avoid the problem of blind speed. That's it. So already discussed this blind speed. When the target is in the blind speed, moves in a velocity of blind speed, then we can't detect this target. So a high PRF pulse Doppler radar is one with no blind speeds with the Doppler space, within the Doppler space. So if you don't want any blind speeds for a target, for a radar, use the pulse Doppler radar. There are basically three, depending on the trade-off, there are three different types of pulse Doppler radar. One is MTI with no range ambiguity and many Doppler ambiguities. So when we'll get this, when you use low frequency or low PRF, we'll get no range ambiguity but many Doppler ambiguities. The second is the high PRF pulse Doppler within range ambiguities and no Doppler ambiguities. So one is high PRF pulse Doppler with many range ambiguities and no Doppler ambiguity. This can be occurred, that is many range ambiguities are occurring but no Doppler ambiguities. That is high frequency, high PRF. If you are using medium PRF pulse Doppler radar, then both ambiguities will be there, but to some extent only. That's it. So let us see what is high PRF pulse Doppler radar. So this is a sketch of geometry of airborne pulse Doppler radar illustrating of scanning main beam, the antenna side lobe illuminating ground clutter, and the strong altitude returns from the directly below the radar. So basically, if they are going somewhere, it will be getting returned due to the clutter, and it is like straight perpendicular to it will be telling the radar that how much height it is. Okay. Now, what is high PRF pulse Doppler? No ambiguities in Doppler frequency, no blind speed, no, but many range ambiguities. Range ambiguities can be resolved by transmitting three redundant waveforms, each at a different PRF. As we already see this, uh, where we have used two frequencies for an example. One is like, let us take this one, okay, and like this. One with another dotted line. Let us take some other frequency, like other color. Okay, at here it will be the peak, uh, at peak, and at some like this, right? Sometimes what happens, this might convert somewhere at somewhere, but within this Doppler space there is no ambit, because when this becomes zero, this signal is there, another signal. So like that. So basically one will counter the other actually. So this so when this orange is zero, this red is there. So like that. So that's what he's saying. Different PRFs actually. So range ambiguities can be resolved by transmitting three redundant waveforms, each at different PRF. So actually, this range ambiguities thing is a different. Also can be seen when you observe my whole video. This is one of the topic where uh, basically the unambiguous distance will not change even if you change the frequency. So that's the main concept there. So when you have three waveforms coming, I have changed the frequencies. What happens? Only the true waveform will be constant, remain constant for every frequency. So if we change the frequency, the remaining will be shifted. Okay, like this, they will be shifted, but the true region will not be uh, changed. So from that is the meaning of here. This range ambiguities can be resolved by transmitting three redundant waveforms, each with a different PRF. Understood? And transmitter leakage and altitude returns are removed by filtering. So if there is transmitter leakage, already we discussed while transmitting, that may cause to the receiver as well. That is the transmitter leakage. And other thing is the altitude thing, that also can be resolved by using a filters. Main beam clutter is removed by tunable filter, that is already we discussed. Okay, that will match with the clutter frequency. Now, high closing speed aircrafts are detected at long range in the clutter free region. Okay, and there is a poor detection of low radial speed targets that are masked in the frequency domain by short range side lobe clutter folded over in range. So if they are moving at close radial speeds, then they will be considered as a clutter. Often, often only a single range gate is employed, but within a larger Doppler filter band. And where is for comparable performance, a much larger improvement factor, that is already we discussed, improvement factor I is required. That is improvement factor in MTI, right? Factor is required than lower PRF system, since the higher PRF results in more clutter being viewed by the antenna side lobes. Okay, so that can be resolved by using a proper large improvement factor, and the antenna side lobes must be quite low in order to minimize the side lobe clutter. Next, range accuracy and the ability to resolve multiple targets in range are poorer than the within other radar. So range accuracy and the ability to resolve multiple targets in range are poorer than with other radars. So when you use this type of high PRF pulse radar, these are the properties that it will have, and also we have discussed in this only how to resolve also. Few of them got resolved with some properties. Now coming to the medium PRF pulse Doppler, has both range and Doppler ambiguities. So there is no clutter-free region as in the high PRF system. No detection of high-speed targets will not be as good as within the high PRF system. So we can't both are like there will be no clutter-free region, and there will be clutters. Okay, and high-speed targets can also not as can't be detected as good as high PRF system. Next, fewer range ambiguities mean that there will be less clutter seen in the antenna side lobes, so that the target with low reliable speeds will be detected at longer range than within the higher PRF. So basically higher PRF can't detect medium speed, right? Medium speed target, but this medium PRF pulse Doppler can detect. The trade-off of detectability of high-speed targets for better detection of low-speed targets often makes the medium PRF system prefer over the high PRF system for airborne airborne fighters are because those basically the targets that are being detected by these helicopters or fighters are much slower compared to the speeds of the platform, right? So they mostly use this medium PRF only because it is most basically the detecting ability of this medium low speed targets is best for medium PRF pulse Doppler. Next, often the medium over the high PRF for airborne flight radar application if only a single system is used. The altitude returns can be eliminated by radar gating. It's a range gating and more range gates are required than in the higher PRF system, but the number of Doppler filters in each range gate is less. Okay. Fine. Yes, 7 or 8 different PRF must be used to ensure that the target width has the proper Doppler frequency to be detected on at least 3 PRF in order to resolve range ambiguities. So basically, it will have both, right? And so, think it started. So what he's saying basically we have to use both, right? Sorry, there will be both ambiguities, right? So Doppler ambiguity and also range ambiguity. So to clear the Doppler ambiguity, they have to use 7 or 8 different PRFs must be used to ensure the target will have a proper Doppler frequency to be detected on at least 3 PRFs in order to resolve range ambiguities. So to offer comparable range performance, the large number of redundant waveforms means that the transmitter must be larger. So better range accuracy and range resolutions are available than within high PRF system. The antenna must also have low side lobes to reduce the side lobe clutter. Now coming to the low PRF AMTI, that is airborne moving target indicator. No range ambiguous, but many Doppler ambiguities, right? So blind speeds will be there. Now requires are TACCAR and DPCR. These are the two already discussed in the last video. To remove effect of platform motion. Uh, operates clutter free at long range where no clutter is seen due to curvature of the earth. Okay, and side blown clutter is usually not as important as it is in a pulse Doppler system. So basically it is side lobe clutter is not as important as in the pulse Doppler systems here, and best employed at ultra high frequencies or perhaps L band. Increased blind speeds and lower lower effectiveness of platform motion compensation prevent it use at the higher microwave frequencies. To compensate this, compensation prevents it prevents it use at the higher microwave frequencies. So when you use this higher microwave frequency, you might resolve this. So the lower RF frequency, ultra high frequency of the AMTI radar system is a wider antenna, which has this radar results in a wider antenna beam width than a higher frequency, that is S band pulse Doppler radar, whose mission is wide area. Sorry, basically why this low PRF will be used for the radar to scan a wide area air surveillance. And because of this, there are no range ambiguities to be resolved. Redundant waveforms with multiple purposes are no needed. Multiple PRFs are no needed. For comparable performance, the required product of average power and antenna aperture is uh, less than of pulse Doppler radars. Less than for pulse Doppler radars. Usually simpler than pulse Doppler radars. Cost is generally much less than pulse Doppler radar of comparable performance. Since we are even discussing this topic in pulse Doppler radar, this Low PR of AMTI will not come under pulse Doppler radar, because when we call this pulse Doppler radar, which when we have the minimum value of maximum PRF at which we are able to eliminate the blind spots, like blind speed. But this will not eliminate blind speed, so that this will not come under pulse Doppler radar. This low low PRF. So cost is generally much less than pulse Doppler radars of comparable performance. And so basically, I think this is a trade. Yeah. So in the next lesson, we can see what is a tracking radar. So thank you for watching.